Hello guys, welcome back to our channel Code Champs. In previous lecture we discussed about the linked list concept. Now we are discussing about the single linked list and insertion, deletion and creation of the single linked list. Let us see. Now we know previously we discussed what is a node. Node consists of the two parts. One part is the data part, another part is the address part. Okay, here address means it will links to the another node of the address. For example, like that, it will links to this address will store in this part. These things we discussed in the previous class. Now we have to create the single linked list. We know what is single linked list. Single linked list means only forward traversing. There is no backward traversing. We know what we discussed in the previous class. Now, what is self-referential structure? Before going to the insertion, we have to know about the self-referential structure. Self-referential structure means it is a structure. It will point to itself or it will point to same data type. Now we can see by the simple structure. Here we declared one structure. Here struct node. Struct node is a data type. Struct node is a data type. It will store the data part and link part. Okay, here if you see here link is a pointer. What is this? Link is a pointer. It will points to itself. If you see link is a pointer, it will points to itself. What is that? Struct node. Like that. Here link will store the address of struct node only. Same type of the data or. So we discussed about self-referential structure. Now we are going to basic code of the linked list, basic creation code. Okay. Now we know node consists of the two parts. One part is the data part, another part is address part. Address part of the another. Now we discussed in the previous video that first node address will store in the. So we discussed about the self-referential structure. First of all, in previous video we discussed that node contains the data part and address part. In this address part, it will link to the another node address. For example, if we take that, for example, if the data is 10 and this 2000 address will store here. These and all we discussed in previous class. Now we have one doubt. The first node address where it will store. Here we are creating one head. Head is a pointer. It will store the first node address. So the first node address will store into the. For suppose first node address is 1000. The head will store the first node address. So head contains the first node address. So we have to create one. We are allocating the memory for dynamically. Head equal to struct node malloc size of the data type. Here we are entering the data. For example, head 1000 points to the data and link part or address which is linked to another address. So we are entering the data into the head part. Head part points to this data. So we are entering the data into where we are entering data. Head points to data. So we are entering the data like this. Initially head is just we are creating just head. Initially we are not linking this head pointer to the any another node. So head links to where? Head links to null. So in this code we explained creation of the head and now we created here three nodes. First head will store this address part and it will store the address of the next node. It will store the address of the next node and last node will empty. So it will point last node consists of none because it is not connecting to any another node there is no another node after this, so it is null. Now by pictorial representation we are understanding this. Now convert this into code, our code. Okay, initially we created for head will store the address of the first node. Now create another node for the second. Struct node second, that is equal to, here we are allocating the memory dynamically. Struct node malloc size of struct node. We are entering the data to the node. By directly we are entering data by dynamically or statically. Here we are entering the statically. So second data has 20, and it will initially it will link into the another node, third node. Initially the node links to null. So we have to link this second node and this first node. How we are linking? We are linking head. This is head data. This is head link. So we are storing head link. We are storing this second node address in the head link. So we have to connect these both. How we are connecting? Head link is equal to second node address. Second. Same thing we are applicable for second node to third node also. So we are connecting another node. Is equal to struct node malloc size of struct node. Same thing here. Third data consists of 30. It is linking to the null. Now we have to link the second node with third node. How we link second node? This is second node data. This is second node link. In second node link, we are storing the address of this node. So how we are linking? Second node linking to the address of the where? Third node. Like that we are connecting the each node, and this is the basic pictorial representation and code for the understanding. Now we have one doubt. This is if have 20 codes, then it will take a more time. Struct node second, third, fourth, like that. And the memory also wastage. Why? Because we are creating the malloc 20 times. It will more time taking and more memory wastage. So we don't need like a struct node third, struct node second, fourth, like that. We have to create one single node. We are giving that name called current. Whatever name, it is not mandatory. My convenience, I am giving the current. So in this current only we can create more than the one node. Let us next see that code also. Now we can see the code. Here initially head is pointing to the first node, and the first node pointing to the second node pointing to the third node. Here if we have to traverse with the head, it is not possible. Why? Because if we traverse with head, then it will connect to this. If we have to traverse head, traverse means moving from taking one point and moving to all the nodes one by one. So if we use the directly head, then it will connect then we will disconnect with first node. It will connect to the second node. Then it consists of the 200. the first node will gone. So head is unfixed, so we can't move directly like this. So we are using the temperature, sorry, temp. Instead of head, we are storing the head into the temp, and we are using the temp for the traversing to each node. So initially head is storing the first node, temp data. Initially it is pointing to the null. After we are storing the temp to head. With here we are storing head into the temp. So now we are creating the node name. We are giving the name as current. My convenience when I am giving the current. It is based upon our requirement. Current equal to struct node malloc. Here I declared some data 10. Current linking to the initially it is also linking to the null. Initially null. After it we are connecting the first node to second node like that. Head means temp. Initially temp is on. Here we are linking first node to second node by calling temp link equal to current. Initially temp is 100. Temp link means this. This is temp is 100. Temp link means this. Temp link how? 200. 200 means it is the address of the second node. Then we are connecting the first node to second node by using the temp link is equal to current. After we are storing this current to the temp. Now current, how much the current is 200. After the temp become how much? 200. Like that. Same thing applicable for the third node also. Now temp link was 200. Now temp is what now 200. Temp link is, this is temp link. This is temp link. Temp link is pointing to the 300. So what it become? Temp link become 300. Like that we are connecting the second node to third node after storing. Temp equal to current. Here we created the third node and second node. Or instead of writing these two statements, we can write directly, like how initially head is what? Head is initially 10. Okay, it is storing the address on the first node. Head is 100. Head link means head is 100. It is linking to the 10 and 200. It is initially head is 100. Head link means 200. Now head link means head link. Head link means 300. Head link 300. So instead of calling these two, we can write head link is equal to current. Like that also we can store. Let us, if you not understanding, assume that is a train bogies. Here head is like an engine of the like that we are connecting the head to the first node. Assume that this is also train. So here is the basic representation of the simple linked list code. Initially first node address is 100. This 100 was stored into the head pointer. So another this node address is storing. This node address is 200 storing into the this node, and similarly the last node address is storing to the previous node. Like that, this is the pictorial representation. This is the graph. Now we have to print this all three these things. We can't use directly head because of if we use header, head is in fixed position. If you said it will lose the link for first one. If we link initially head was linking only this. If we have to link head with, we have to traverse using by head. It will move to the second node. Then it will lose the link first of first node. Then the first node will lose. That's why we are using here temp. Temp is an temporary variable. So we are storing the head into the temple and temp, and temp is we are using for the traversing. Initially temp is 100. Now we are using the keyword we are using the keyword temp link equal to current and temp equal to current. What is here? Here temp is 100. Temp link was, what is the temp link was? Temp link was this. This 100 was linking to the 200. So temp link is what? Temp is 100. Temp, this is temp link, this is temp. Temp link is how? 200. Now we have to store this 200 into the temp. That's why we are using temp equal to current. This is the current. What is this? This is the current node. We created for another node. Like that. Similarly, now temp is connected to this. Similarly, again, now the temp was 200. Same thing applicable for third node also. Temp is 200. Temp link was how? 300. This is the temp link. Temp link. Temp link. This is temp data, temp link. This is the link for now in like that. So now temp is 200, temp link for was 300. So what is the temp link here? 300. Now we have to store this 300 into the temp. Temp equal to 300. So temp equal to, what is this? What is the node? What is this node? Current. Temp equal to current. Like that we have to give. Or if we use, we can write by using the current, we can write manually one by one, or we can use the for loop also. Taking n from the user, we can use the for loop also, or we can write like this also. Now here we are giving the data and linking statically. We can give the dynamically also. How now? By using the scanf %d comma, where we are storing the address into the pointers, head pointing to the data. Like that we can give the dynamically also. Here instead of we are using these three lines, we can use head link. We can use like this is also. Now we can see the code. In this code we are seeing the count of the code. That means how many nodes present in our given code. We can see that is also. Initially our count is 0. Int count is equal to 0. While iterating this, while temp variable is moving to each node, the count will increase. How it will increase? By when initially count is equal to 0. Initially count is equal to 0. Whenever temp is iterating, initially temp was 100, after temp will become 200, after it will become 300. That means temp is updating with temp next. Temp is updating with the temp next. While temp is updating with the temp of next, we have to increase the count plus. So we can use the while printf statement. Here we are giving the count plus. Each time, first of all, until temp get lost. That means initially the temp was 100, temp link is 200, after temp link is 300, after temp will replace the 200, after null, until reach the temp last node. Last node means that is null. Up to null, we have to do like this. The count will increasing. After we have to print the count. Enter %d comma count. So this is our basic representation of the single linked list and the number of nodes present in the single linked list code. Now we can see the adding of the another node in the at beginning. First we are inserting the node in at beginning position. So let us suppose discuss there. Let us assume this is one. Initially it is one node. Now our aim is we have to insert the beginning. Beginning means this position, first position. So we are creating for another node called insert. I am inserting node. Start node of insert equal to malloc struct node. I created one node called insert. Or suppose data is 40 and initially it is linked to null. It is linking to the null. So our aim is we have to insert, we have to update this new node into the first position. So 40 insert is storing the address of this node. Let us assume this address would be 400. It is null. We have to insert this node into this position. How we can insert? So we have to link this address to this part. Then we have to update this 400 to the head part. First right, after left. If we first we have to insert in head, then head will disconnect with these nodes, then it will have only this node. That's why we have to always go for the right linking first. So first we have to link this 100. How we can link it? Insert link to this 100 was where this 100 was present in head. So insert link 100. After we have to update this head into the insert. So head equal to insert. Like that we can insert the node at beginning. We are discussing about the insertion of single linked list node at the in previous video we can see at the beginning. Now we can see at the end. Before that we have to know about the difference between the temp until the null and temp next to is not equal to null. That means temp not equals to null means it will traverse all the nodes including the last up to this null last node. But temp next means it will traverse up to the last node before one. That means here we can see initially temp is 100. Okay, temp link means initially temp is 100, temp link is 200. Temp link is 200. Temp link is 200. Here temp up to where temp link is not equal to 0. This temp temp link is 200. Condition true, it will go the inside. After temp equal to temp link. That means now the temp value was 200. It will replace by the 200. That means now temp equal to temp link. That means now the temp value was 200. This link was this. Where here we have null. So condition false, it will come outside and the temp link is equal to end. Here we are creating the now one linked list called end. 40 null. So we have to link this for suppose this 100 was 400. Now we have to insert these 400 address into this previous null. That means temp next. That's why we are giving the this temp is not up to link not equal to 0. This is the difference between the temp not equal to null and temp is next is not equal to the null. Like that we are storing to the end.